Yeah. Stop there. There is a stop there. Left hand side. அதை கூப்பிடு தங்கச்சி. Hello.
Okay. Hello. I still can share my presentation. Dr. Samuga, can you display off your presentation sharing?
Yeah.
Yeah.
Can I share?
Can you? Yeah. Can you stop your displaying? All right. I try to share my. Okay. Okay. I try to share my presentation now. Uh, okay. Is my presentation can see everybody? Is my presentation can see?
Yes, we can see.
Yes, doctor.
Okay. Thank
Yes,
you.
we can see.
Assalamualaikum warahmatullahi wabarakatuh and good morning. Thank you to chairperson and everybody here. So this day I was supposed to be in group H, but because this afternoon I have no time, then with the permission of the committee, I enter into this group F. So thank you for to all. Well, today I will present the result of our study entitled Study on Workability High Strength Concrete Containing Pineapple Leaf Fiber, or PALF. PALF. The background of this research is due to some study wanting to increase the strength of concrete, especially overcoming the weakest part of concrete. So what the weakest part of concrete? So that is the interfacial zone in the matrix where concrete particle must hold the shear when the concrete is encumbered. Yeah, load work on concrete. So some studies adding the fiber to concrete mixture to increase the bridging force to avoid micro crack in concrete matrix. Yeah. Oh, it's not changed yet. Not full screen. Okay. I don't know why. Okay. Manual like this. This one. Okay. All right. Okay. Yeah. So the background of this research is due to some study wanting to increase the strength of concrete, especially overcoming the weakest part of concrete. The weakest part of concrete is interfacial zone in the matrix, where the concrete particle must hold the shear when the concrete uh, is encumbered. Uh, okay, some study add fiber to concrete mixture to increase bridging force to avoid a micro crack in concrete matrix. So in this study, we use a very abundant and washed pineapple leaf fibers or pulp. Okay. So In the meantime, the real problem of this study is the presence of fiber in concrete will affect the workability performance of concrete. Fiber will occur fibrillation. The presence of fiber in the concrete mixture create friction between fiber and the concrete particles and inhibit the flow of the fresh concrete. So that's the fibrillation. Moreover, fiber will affect the moisture content in the concrete mix. Uh, Fiber will affect the moisture content, and then the mixture will dry and because due to absorption of the fiber. Therefore, the objective of this study uh, is to investigate the influence of pulp on workability in high-strength concrete, further exploring the slump character of high-strength concrete mixture containing pulp with water-cement ratio variation. Okay, this is the material and method here. Table 1 shows the result of analysis of concrete material properties as constituent of concrete to develop the high-strength concrete by Indonesia national standard. This is figure of pineapple leaves fiber. The fiber has been processed and spirited from the rest of the leaf. Each fiber has a diameter of approximately 12 micrometers, which has a tensile strength is 170 megapascal. To develop the high-strength concrete based on Indonesian national standard, where the composition of the proportion of each variation, as in table 3 here. In this study, we are using superplasticizer constantly. Superplasticizer to help the viscosity of the mixture so that the concrete will can flow. In this case, there are 3 variations which amount of pulp. This is 0.04, 0.09, and 0.15 weight of cement. Yeah, weight of cement. So deliberately, fiber is not mixed in large quantity because it can interfere the workability and moisture of the concrete. So this is the sample of concrete produced from of cube with size 15 centimeter each side. So total 24 sample for each variation for 3 treatment age. It's 7, 14, and 28 days. This figure shows this is the 28th day, which the fiber is not seam again. So this the fiber drown and bond to the concrete matrix. If the 7th day, the fiber still visible here. Yeah, it's not a fibrillation completely. So result and discussion. Figure 2 and 3 show the result of the shift analysis of coarse and fine aggregate. This is the coarse. This is fine aggregate gradation. Where both are included in the condition of high concrete quality aggregate. So the passing gradation is included in the condition of standard here. Table form shows the average height of the slump in all variation, where the lowest slump is with water cement ratio of 0.35 here. It is the lowest slump. and the highest one is the 0.41. Yeah, so that the tendency of the water cement ratio relationship between slum here, it can map with the water cement ratio. Figure 6 shows the relationship of concrete strength between water cement ratio and compressive strength, where the strength of concrete with the lowest water cement ratio 0.35 here is the highest compressive strength. This can be understood because all studies show decreasing the water cement ratio will increase the strength of concrete. And this study of variation 0.09 water cement weight of cement is the highest one. Figures 7a, b, c, and d show the relation between three variables: compressive strength, water cement ratio, and slumps. This four image is mapping the tendency of these variables of four pulp variation: normal, 0.04, 0.09, and 0.15. So all the trend variation is the increase in water cement ratio. This is one, coupled with the slump in the yellow one, along with decreasing the compressive strength. So all trend is similar here. So, but that is interesting is that the strength value of four image here, for variables against the water cement ratio is the same constant. We can see here the number is still same, constant, constant to against the water cement ratio. So the conclusion of this study is the addition of fiber high strength concrete affect the slump value, but with water cement ratio and pulp percentage amount, they reduce the effect of the reduction. Lack of water due to absorption of fiber can be overcome by adding water following the absorption capacity of water by fiber. The water cement low ratio increase concrete strength despite pulp presence in concrete. The presence of pulp in concrete helps in bridging micro crack on concrete, thus increasing the compressive strength on concrete. The relationship between concrete strength and water ratio has the same tendency for concrete with all pulp variation. So that was my presentation. So I apologize if something has been said or mistake here. So thank you.
Okay, thank you, Dr. Joseph Hadi Prama, for the nice presentation. And now I'm open for the Q&A session to the floor. Is there any question? Is there any question from all the participants and presenters? Okay. No question for Dr. Joseph? Okay, if there is no question, I would like to thank again to Dr. Joseph Hadi Prama for the presentation.
Yeah, you're welcome. Thank you for all.
Okay. Okay, before we continue our session, I would like to remind to all the presenters and participants. Okay, I would like to remind to all the presenters and participants to fill up the attendance form at the chat. please fill up the attendance form at the chat. Thank you. Okay, without further delay, I would like to invite our second presenters, Dr. Shanmuga Sekar from the Faculty of Civil Engineering, University Technology Malaysia, Johor Bahru. Dr. Shanmuga will deliver his presentation on the topic of investigation of dynamic factor, rail stress and track foundations, modulus of ballasted railway track for different bed conditions.
Yes,
Please
yes,
welcome Dr. Shanmuga.
yes, welcome to everybody. I am Shanmuga Sekar Tenappan. Can you hear everybody?
Yes, we can hear you.
Okay. Okay, welcome to everybody again. Let me share my file.
Yes, sure.
Share the file. This one.
Exactly.
Huh? This one. File where?
Entire window.
Huh?
Enter.
The share.
Open.
Okay. Window. Huh?
Set.
How to share the file? Where the file? The file. Share the file.
Open the
Yeah, just
slide. Open your slide. Open your slide. Open your slide. Open the slide.
okay, wait.
Go back moving. Oh, please.
Okay.
Entire.
Sorry for delay. Okay. Huh? And share is it? Step.
No. Start.
Okay. Okay. Stop sharing. Stop. Can hear? Hello? Can hear?
Stop.
Okay. Welcome. Good morning to everybody. I am Shanmuga Sekar Tenappan from UTM. He is a PhD student. My supervisor is Professor Dr. Aslan Adnan. I am going to present about this topic. My topic is investigation of dynamic factor. It is a factor that is to compensate the dynamic effect of the rail loading, rail stress and track foundation modulus. This is the foundation for the track for the different ballast and substructure. What is the condition? It will be analyzed using the numerical analysis. Again, I repeat: investigation of dynamic factor, rail stress, and track foundation modulus of ballast railway track for different bed conditions using numerical methods. This is my topic. The right hand side, the figure, that is the ongoing project of double tracking project from the northern to southern section. This is a northern section starts at the Padang Bazaar to south section is a Johor Bahru project. Now is ongoing. I am attached to this project. The second figure, what is this? Is the typical structure of the ballast track and the load bearing function. You see from the figure, the load is transferred from wheel to the rail, then after the rail pad, then goes to sleeper, then go to the ballast, then it goes to the subgrade. So that means the stress level from top to bottom, it is going less. Can you hear everybody? Hello? Hello?
Yeah, yeah,
Hello.
doctor.
Yeah, sure, we can hear you.
Yeah,
Don't worry.
Okay. Next slide. Okay, now come into the, what do you mean by the good track? The track, whether the track is perfectly is okay or not, how do you determine? Normally, after completion of the track, that is the baluster track, there is one machine called, that is a track recording machine. That machine will measure the track quality index. The track quality index, you see the right hand, that is the table, that is the rating one. This TQI is the rate of the 6-7 parameters in the railway track. That is right and left level of the rail, and the alignment of the rail, and the twist, and the cage of the rail is well maintained within the tolerance. This is the average weight of the standard deviation of the reading. It will be captured by the track recording machine. That should be maintained for the track good quality. It must be in the rate of 40. In the meantime, the ride index is measured by the in the car, that will tell the jerk level. Jerk level is the acceleration limit for every kilometer, it will be calculated. That to be maintained in the very good condition is a 1. Then this is the one, is the rate of the track is measured. This is the way how is measured in the track. So this end of the thing is, when we're on board, the passengers should feel the comfort. That means no jerk. That is the acceleration limit they have to maintain, is a 0.0321 G. Then come to, if this is maintained by means of track geometry. If track geometry is perfectly okay, then you can maintain. Then how it is maintained? It depends upon the track integrity. There's a track integrity is a function of measure of stiffness and deflection. These two controls. Then what happens, the stiffness? If it is a stiffness of the track is very high, the settlement will be low, the less stress will be, but less stress, but in the thing is, the load, it will go into the more slippers, then the dynamic factor, it will be high. Then there will be a damage in the ballast, then the deterioration of the track will happen. Then what happens to if the stiffness is low? If the low means, then the rail will settle, then bending moment, it will be more, then the stress in the rail will be more, then finally the deterioration of the track, it will be more. So what will be the optimum value? The optimum value, according to the research, so many researchers, they concluded there is no universal value, because it depends upon that, it depends on the specification of the project. What is the requirement? It varies. So we have to find out for this case here. Then if everything is okay, the rail life will be increased. Then consequently, the maintenance cost will be low. The picture is here. The one picture is, that is the behavior of the TQI and the operational load and the condition of the track behavior. You can see as the load increases for the perfect track, high-speed rail, it will be maintained is a flat. When it comes to the poor track, it will be increasing. Next, when it comes to the stiffness, I would like to define the stiffness. The stiffness is referred and defined by the various literature, various books in various names. It is a track foundation modulus, or the value is called in the C, or this value, or the other literature, normally they say is a K, but the value is all the same, but it is a derivative of the foundation, that's all. Then come to this definition, that means the overall strength parameter. This is the C is the overall track strength parameter. It measures the unit load pressure per unit deflection of the rail. It's actually the spring action. That is the pressure per unit deflection. Then it is a joint performance of the structure. You see the right hand side, this picture, it shows that is a total contribution, the stiffness to the entire track. I take is a concrete sleeper polyester track. You can see from this 43% that is a substructure is contributing. That is the subgrade. Then is a 22. It is a substructure, that is the ballast. Then is a 0.8. Then the rail pad is 34 and a 0.2. So this is depends upon the vertical rigidity of the substructure. Major contribution. That is the major parameter in this is contributing is a elastic parameter. Then other factor in the thing is a dynamic factor. This dynamic factor is multiplied, normally is a compensating factor for the dynamic effect, the moving load. This factor is multiplied in the design of the rail. By seeing this picture here, the left hand side, as the speed increases, the dynamic factor is increases. Also irregularity of the rail and the track condition, if it is a very bad also, it will be increasing. Then come to the problem statement. In the double tracking project is a northern part. The TQI index what I showed you earlier, after completion of the 5 years also, it is maintained in the track is a 40. You see the right hand side, the standard deviation, as the load increases, the period increases, the standard deviation has to increase it. But what happened here is after 5 years also, it looks as if it is a very, very good track. That means the standard deviation not following the trend. Overall, it is concluded, it doubts that is a stiffness, it will be very high. Then it leads to is a not cost-effective design. Then it may be relatively the maintenance high. It will be then there is a necessary to investigate the roadbed material and the thickness and what is the soil parameters and the dynamic factor what they have assumed in the design. So the author interested to investigate on this. As I told you, the track stiffness, little bit I have to touch about the track stiffness, the C value, how it is used in the design. There are two methods being followed in the baluster track industry. Baluster track, that is one is a Taulium method and a DM method. Taulium method is a continuous method. This is a discrete method. Discrete method is a very support is model. This is a continuous beam method. The difference of these two is not much. It's more or less same. But anyhow, accurate is a discrete model, discrete method. So I compared the two design what used in the double tracking for the northern section and the current method. I compared the rail stress computation. The general formula is same with the dynamic factor. Then come to the mean stress, how they calculated in this method is a Zimmermann method. They use the C value directly. It is a C value directly used. When come to the modern method, they have used the D. Actually, it's a derivative of the C. There is no problem on this. But the thing is here, this method, the contribution of the bed, it is not included here in this Zimmermann method. Then come to the dynamic factor is this method. Dynamic factor, according to the design, they use only velocity, that the speed of the train only they have used. But that is not only the contributing factor. Of course, the V is the contributing factor, but the other factor, according to the modern method, by the Eastern method, you have to look the track condition. What type of track you are using, whether high-speed track or normal track, that the track condition, the factor you have to use, then how much accuracy you need. So this dynamic factor, it is a multiplication of the three factors that is a more appropriate. So that depends on speed only, it is not appropriate. So this is the problematic, this is a problem. So it is stated the problem here is there are two things I have to investigate, the track stiffness and dynamic factor. Then come to here is the objective. So in this one, I have to optimize the track design based on the C value by using simple plate bearing test. Plate bearing test is a simple test. This one not required to stop the train, is very easy to measure. No implementation of stopping the train. It is very easy, construction wise easy. labor-wise, it is very easy. Then I have to evaluate the appropriate dynamic factor by using modern method. By doing this, you can choose the maintenance cost, which will be reduced. Then the review methodology. Raise stress is evaluated by the field bearing test, determination test by using the double track project test result. Then other thing I am doing the finite element analysis using the same the plate bearing test for the different thickness of the ballast and how it is varied to the subgrade soil. Subgrade soil I categorize it into 3, low to high. So then let me explain how the raise stress is analyzed. There are 5 steps are there, 4 steps. First is the plate bearing test, which is carried out. The C value is determined. That is the strength of the overall track. Then the mean bending stress. Then you determine the dynamic factor. Then multiply with the dynamic factor. Then this final stress is to be checked for the fatigue strength is allowable or not. Then let me explain the steps what I told. First is a plate bearing test. This is the test. You can see the right hand side, the track is completed. It is ready to lay the slipper. This is a plate bearing test, the site. You can see, okay, this is the one, the field test, it has been carried out at the double tracking project. Is a load cell here. This is a schematic diagram. The load applied is a rail seating load. Is in a two increment. This is a first cycle and second cycle. The graph is drawn is for a first cycle and second cycle. This first cycle, it is like immediately the track with the voids. That means it is then I go back here. It is actually idealized diagram for the plate bearing test. When it is a first cycle, it will be a linear. When it comes to the second cycle, this cycle, all the voids are filled. After tamping the track, it will be simulating the accumulated loading. That means the actual stiffness of the track can be measured by the second cycle. It is actually a non-linear behavior. The slope of the thing is calculated. Then the C value divided by the area of the plate, what is used. Then you can get the C value. C value is the pressure by area. This is the parameter we are getting from the test after completion of the track. From the C value, we calculate the bending moment by using the Zimmermann analysis. I am using the 3-wheel load, the envelope of the bending moment and the deflection you have to get from the Zimmermann, the envelope. After getting this, the raise stress is calculated. Then is multiplied with the dynamic factor. Then after getting the dynamic factor, the fatigue raise stress is whether it is within the limit or not. We have to check with the Smith diagram. The left hand side is a Smith diagram. From O to A, that is the envelope. This is the envelope is the mean stress. The allowable limit is from P to PA and the C to A. When come here, we are using the UIC 54 rail. This 54 rail is a 900. 900 is a yield strength. Is allowable FY is a 540. So the stress limit is you have to maintain within this. What is the stress limit for this? It depends upon what is the temperature in the country and what is the manufacturer's residual stress. That is a residual stress is from the x-axis is 180. So this is the limit, they cannot exceed it. So this is the limit is a 280. This is the way to get the final stress in the rail. Then come to here. Then after that is what I did is a numerical. I did the numerical analysis. I modeled the plate bearing test is a simulation of the tank. That is a 2 method I did for. One is a static, another is a dynamic analysis. The stat in this in my model representing the subgrade, subballast and ballast. This subgrade is a 3 subgrade I take. One is from in the range of 25 to 48. That means a low, medium, and a high, according to the whatever the soil available in the site. Then this subballast and ballast The subballast is a constant. This is a ballast. Ballast is a one varying from 300 to 100. So overall, this material is a granular material from 600. By the finite element analysis, I am varying this thickness and for the different subgrade, and what will be the deformation from the finite element analysis I got from the analysis. That is the static analysis. The aim of the static analysis, what will be the deformation for the different subgrade and the different ballast thickness. Then come to the dynamic analysis. The same model has been used. In this model, a different speed has been created to get the different frequency for the different speed to get the dynamic stress at the subgrade level, so that to find out the dynamic factor. So for this, I have used the load, the 50 kilonewton, the load which comes to the rail seating load coming to the one rail seat, 50 kilonewton. The load I use for this is a KTM double track. They use the locomotive with a 200 kilonewton. This is the locomotive. Then this figure is what I created, the amplitude time graph for the maximum speed 160 km per hour. So the aim of this is what is the dynamic factor derived from the finite element analysis for this 160 km/h. So coming back to the result, then the result what I got is this vertical displacement for the different grade. Then is a ballast thickness. Then I got the derived C value. Then is a mean stress. So this range is 2548. This is a vertical displacement. Is from maximum to this is the range. Then the thickness of the ballast thickness is 100 to 500. Then derived C value and derived mean stress. Then this is the one, this is the first cycle and second cycle picture of the displacement graph for the 48 grade. We can see we can see the displacement is increasing. There's a maximum we got is 1.2. After getting this, what is this? After getting this data, I have simulated the graph. I found the correlation equation for this. I got the correlation equation for the different subgrade or the different thickness. What will be the expected the C value and rail bending stress? Then come to the dynamic factor. The dynamic factor from the analysis, I got the linear equation, this equation for the dynamic factor 160 km per hour based on the Eisenman method. I got the 2.9. This is the one, the dynamic stress at the subgrade for the different subgrade. This one I look for only 300 thickness because the project they use the 300 thickness. Then this figure is a dynamic factor. I compared to the other modern method, JNR method and other methods. The finite element method is a little bit high. This is the dynamic factor obtained from the finite element analysis. That is what I am getting for the 160 km per hour is a 2.6. Then I compared the field test with the finite element analysis. First is a settlement graph. You can see this for the northern section and this one southern section. I have divided into two sections. So generally, the displacement is very minimal only. The 1.71 to 2.83. This side is a 2.83. This side is a 0.71. Then actually the displacement is minimal, but there is an increase in C value and rail bending stress. The less displacement, it will be more steep, and the rail stress, it will be less. The displacement decreases with the ballast thickness. The displacement decreases with the increase of subgrade modulus. The subgrade modulus is a dominant factor, which is the one is controlling the deflection and the vertical stress on subgrade. We can conclude from the graph. You can see This one, the site 1 and site 2 and the finite element analysis. The finite element analysis settlement also more agreement within this. It is the between the two values. Then is comparing these two. Comparing these two, the site 1 we got is a 0.7 mm, site 2 is a 2.8 mm. It looks the rail experience less bending stress in this one in the site 1. It is a much shift than site 2. The allowable live load stress in this one by using the Smith diagram, the allowable limit for this is a 280 MPa. For when we interpolate for the 180 to our country, this allowable limit is a 280 to the live load. So site 2 reaches to the 187 to 280, that is nearly is 74%. Then the site 1 is 161 to 180, that is 80%. It is achieving. This is the zone is a free zone. That means the 80% achieved by this one is a 70% is achieved by the first, 74 is achieved by the site 1. So what you can conclude, the site 2 has the tendency to experience more fatigue stress. The deterioration rate, it will be higher here. Then there will be ultimately the site 2 experiences more maintenance cost. So in the conclusion, so static and dynamic analysis of ballast track structure has been studied for the different railroad bed conditions. That means it's a different ballast thickness by changing the different subgrade soil, by assuming the numerical by using numerical methods. In this, we have taken into account the plastic properties of the subgrade soil and ballast. That is non-linear behavior also it has been captured. The track stiffness comparison has been made by the two sides. A simple plate bearing test method was from that we use the force displacement graph is a conventional graph method, which is a very cheap method when compared to the new method which requires the more implementation, stop the train, and the labor cost will be very high. The improved method, what I adopted is a equivalent track thickness I have added with the bearing pad. It is accurate method. Simple mathematical evaluation were developed to correlate the variable ballast thickness. This will be very useful for the QA/QC control. The dynamic factor was evaluated simulating the expected frequency and compared with the various methods. Incorporation of this dynamic factor and the equation will improve the accuracy and the reliability of the track construction. Then we can maintain the maintenance standard. Thank you.
Okay, thank you to Dr. Shanmuga Seka for the interesting presentation on the railway study. Thank you very much. Okay, now I open to the Q&A session, to the floor. Is there any question? Okay, Dr. Syed, please.
Good morning, everyone. Thank you, Doctor, for a wonderful presentation. Just my question is, did you consider the dynamic effect for curved section of railway track?
Yes, dynamic factor, it is added that in my analysis, I have found out is a 2.9. That's why I have carried out the dynamic analysis.
This is for curved section. Did you consider also curved section?
Sorry, which section?
The curved section of railway track, because the dynamic effect can be different and arise in curved section due to the small radius. Did you?
Oh, curved section, no, I didn't analyze for that.
Okay.
Actually, I built up one model only. It is assumed only, no geometry is here.
Okay.
The factor we have to add it. We have to factor it. We have to add it when you calculate. But maybe the stress you have to increase it. The axial load, when it comes to the curvature at the camper, you have to increase the factor. Say you got the 100 kilonewton, because of the abnormality of the track, maybe your factor you have to increase it.
Okay, great. Thank you very much. It was a great presentation.
Thank you, thank you.
Okay, thank you, Dr. Syed.
welcome.
Another question, maybe from Dr. Dwi.
Yes, small question to Dr. Sarmuga.
Yes.
Yeah, my question is, how long far the red index can be obtained in level 1 in your southern region? It is possible in range 60% on the track in level 1 of riding index.
Sorry, sir. The TQA index
is how long far the red index can be obtained in level 1 in your southern region?
Actually, this is a very confidential, but actually, this is the value they are getting is a 40. Is a 0 to 40. 40
Yes.
for the condition if the track is perfect.
Okay. So it is possible the track length can be reached in 60% in level 1 of riding index?
60% means it depends upon the traffic, but as the load increases, it has to go. But what we observed, it is the flat condition. That means it is a conservative design.
Okay. This small question so for another college is Mrs. Tia will give a question.
Okay, Mr. Sarmuga. My name is Tia, and I'm from Agency of Assessment and Application of Technology from Indonesia. Thank you for your presentation, and I want to ask you some questions. The first is, what kind of software that you use for the numerical analysis, and is there any specification parameter that you input for the simulation analysis? Thank you.
Yeah, actually, what I have used in the tank, it is a rigid at the bottom. The rigid at the bottom, that means the substructure, the subgrade, after 600 mm, it is assumed as the hot soil or rigid, that means a rock base. That is why I have used the rigid. Then the interfaces are always bonded. That is interfaces means the ballast, the subballast, the ballast to subgrade, it is a bonded interface.
Okay, thank you, sir.
Okay.
Okay, thank you. Any more questions?
Okay. Thank you, Dr. Doctor, for your presentation.
Thank you.
Thing
Welcome.
regarding your explanation about the double track rail at southern region. Is that in Johor? That the one that?
Yes. There's the project is now ongoing from GCOMSE to Johor now.
Yeah, from single track to double track, right?
Yes. That is the track portion. Yeah,
okay.
That is the portion not completed. Other portion all completed. There is a second
okay.
section.
And another thing that catch my eyes is your statement in problem statement slide. Okay, where you said that the track is in good condition for 5 years, but there's another statement further below. It said that it is not very cost-effective design. Can you re-explain? I might miss of the information during your explanation.
So actually now this project, the southern section is an ongoing project. That one is a northern section. It has been completed in 98 something they have completed. After completion, After 5 years, the tendency of the standard deviation must to decrease it. But you see, every 2 years, they will measure the condition of the track. Actually, it has to, the deterioration rate, it has to decrease it. Deterioration rate, it has to increase it. Then they will go for maintenance. But this track after 5 years also, the track condition is very, very good. That means it depends upon the track. You see, for the high speed rail, you have to construct, means your start of the design, it will be high. Your expectation must be very high. The track, there no settlement, but the cost will be very high for that. For the normal track, standard track, no need that much amount is required. So in that point of view, I'm telling you, it must be over designed.
Okay, thank you so much.
It might be.
Yeah, it might be because still in good condition, right?
Yeah.
And then now that we try to we want to replace to upgrade to the double track system.
No, not like an upgrade. That means my investigation shows that when I get the settlement and compare, that side is a 0.7, this side is over 2 point something. That means it, of course, it is not much difference, but there is a difference there. From this, I can conclude that this will get the more stress than that one.
Okay, thank you, Doctor.
Okay. Welcome.
Okay, thank you, Dr. Nawati. Is there any more question? Okay,
Sorry,
there is-
Dr. Samgan. My name is Chingtang. I want to ask about is it you have considered the elastic link between the track and your final element software? And second question is, if you say that settlement, because the track is very long, right? Few kilometer, then if some portion is very bad soil, then how you control the settlement? Is it the settlement will affect your analysis result? Because as we do a model, normally the soil will affect the real stress, correct?
Yes.
Then my question is, because the track is very long, few kilometer, how you make sure that the whole stress, the real is in the good soil condition?
Good soil, that is why once say we take is 1 kilometer, it has been completed. You might have the soil profile for the particular portion. You might have the soil profile. You might have assessed the elastic modulus of the soil. The elastic, based on the elastic property of the soil, you can estimate how much the settlement you can expect. What type of soil? So this one I have considered as a 3 soil conditions. One is a low 25, then other is a 30, another one is a 40. So that is in our project also, there must be the criteria, the settlement of the track is not to exclude for 25 mm. So you cannot take say it's actually, you have to take the representation of the stretch before doing it. You have to do the borehole. Say, of course, the soil, it will be varying for the different length, and the soil treatment also different. Sometimes it will be filled, sometimes it will be cut. The different method also they use, like a stone column and R&R, like that. The final thing is, what is your E modulus you are getting from the subgrade?
So based on your model, you are using the spring value to design instead of fixed value.
The fixed value, fixed value is the one is, I am assuming, after the 600 mm, the subgrade, it is a rigid. So when come to the model with the laboratory, I have to put the box, then I have to assume as a rigid there.
When you design as a rigid bed, that means you don't have a settlement, correct, in your model?
Got settlement. The settlement with the subgrade is 600. Yeah, I'm
Subsoil.
assuming the
Just mean,
subsoil. Yeah.
because of the soil, like just now you say, you have considered 20, 30, 40, the settlement of the ground, correct? But you cannot put in the rigid support because rigid is no settlement. You should put in a spring. Am I right? Am I correct?
No, after 600, I am assuming as the rigid. After 600, the 600, it will be representing your E modulus. The 600, the subgrade, I am assuming my model.
Okay.
So whatever the settlement it will care. Actually, by my model, you can see for the E47, that is a soil is a stiff. That one I am getting a less settlement. What is of my final value is I have to get the C value. C, that is a total contribution of the stiffness by the subgrade and the ballast.
Okay. Okay. One more question is, when we know that concrete track and ballast track will have a different elastic
Yes.
between the rail and the
Yeah. Both the structural system is different.
Yeah, have you considered that, the elastic link? How you consider that?
No. My scope is for the baluster track, not for a non-baluster track. Non-baluster track, the modeling all different, because here there is no ballast involved here in this baluster non-baluster track. Directly it is seated on the concrete.
Okay, can.
The
Your one
behavior is
is the
different.
ballast track.
Mine is a baluster track.
Okay, can understand. Thanks.
Okay, thank you. Thank you to Dr. Shanmuga Seka. And
Welcome.
thank you for all the questions. Okay, I have to control. So sorry, I have to control the time for the next presentation. Okay, now we move to the next presentation, and I would like to call upon Dr. Dwi Agus Purnomo from Center of Technology for Transportation System and Infrastructure, Indonesia, with his slide entitled Initial Implementation of Structural Health Monitoring System of a Railway Bridge. Please welcome Dr. Dwi.
Okay, thank you, Chairperson. Assalamualaikum warahmatullahi wabarakatuh. Good morning for all participants online. First of all, we would like to thank the GCOMSE committee, which on the day we were able to attend this event. In accordance with today's agenda, we will present our paper presentation entitled Initial Implementation of Structural Health Monitoring System of Railway Bridge. In this paper, we discuss in 4 cases. First is introduction, and then a research methodology, and also research and discussion, and then last is concluding remarks. So we move to introduction. Next. Why we choose entitled initial implementation? Because of we don't have like workshop drawing of the railway bridge as my research object. So that's why we start from zero from this research. So according to the introduction, based on the history, we found the fact that bridge maintenance is one of the main cause of operating rail transport. The maintenance of railway infrastructure plays an important role in the operation, transportation system, and infrastructure. Then development of a railway system reliability model by implementing structural health of monitoring system and conducting design view to determine the level threshold for the flexion and vibration of the bridge. So the purpose of this study first is to analyze the strength of the attached profile against the working force, especially the live load of the rail line. And second is to know the deflection that occurs. And the third is to know the natural frequency that occurs. And number 4, to develop expert system. Next, we move on to literature study. Based on this literature, we found the fact that Indonesia many railway bridges were built more than 100 years ago. Many of those railway bridges have been structurally deficient due to gradual deterioration with time. The loading condition railway bridge have changed in recent decades due to increased freight volume. There has been an increasing demand for improved condition of transport infrastructure in Indonesia. And then the maintenance of railroad infrastructure plays an important role in railway transportation. Actually, the bridge maintenance has been performed mostly utilizing visual inspection method, but only defect demand when it is possible. A bridge health monitoring technique is necessary rather than visual inspection alone, and it may not be adequate. Next. We move to research methodology. Left side is a flowchart of activity of the study in research of the railway bridge. The bridge is located in province of Lampung, South Lampung, near in Tegrineng district. The flowchart say that we start from the primary data and also a reference of standard. Whereas with this primary data, we can enter to the bridge modeling, and whereas in the bridge modeling we get many load of the bridge modeling, many type of load in their place like left load and others, and then we analyze with this load items to we found the deflection, stress, bending moment, normal force, displacement, and natural frequency. And through this data, we use dashboard design to evaluate the structural health of the bridge. And then this is finish of the progress of the study. And based on the research methodology, we discuss to matter. First is to evaluate the existing steel railway bridge structure. In this case, there were 3D detail model of the railway bridge and also the analytical calculation using FAM. And then discuss about the loading combination of the railway bridge. In this case, there were item of to equalize all the truss geometric of railway bridge and obtain the completely symmetrical on uniform bridge. And also we apply Indonesian national standard and also Indonesian Transport Minister regulation on technical recommend for railway bridge and also technical recommend of railway line and action. This is 3 standard we obtain to optimize my analysis. And then other methodology is we develop transfer data acquisition. Based on the data acquisition, whereas the sector health monitoring system cover the component of the data retrieval process via a sensor system with parameters of deflection, stress on bridge, and vibration. Via the base system, the result of sensor monitoring are processed and sent directly to the data acquisition module or DAC in the bridge location area. The result of the DAC data collection are sent to the store through the gateway into cloud storage. The infrastructure control center can utilize the actual data on cloud storage to monitor bridge condition online in dashboard. Based on the data set on the cloud storage, then the set of view of the bridge aspect in the near future, then the bridge health prediction system can be developed. This is a drawing in the right side below. Yeah, this is the process of the sensor data transfer flowchart. And next, this is a highlight in the my architecture of the ESPA system involved in this my research. Left side is architect of ESPA system, whereas the ESPA system cell consists of the client interface, also knowledge base editor, also rule transistor, and also rule engine, and also rule object process. And ESPA system is involved with the knowledge base. And right side is a component of ESPA system, whereas we involve also the interface engine supported by the explanation facility, and whereas the interface engine we involve knowledge base and also knowledge base acquisition facility and also user interface to support the expert and user. Next page. We discuss with result and discussion. We discuss about structural we discuss about structural characteristic maximum capacity. In this case, we found the fact that the load of bridge requires that load acts on the bridge are not greater than the bridge capacity, and the bridge's capacity ratio and the applied load is less than 1. And we discuss with the maximum bridge deflection. In this case, we found that the maximum deflection limit for the frame is L per 1000 or equal to 51.6 millimeter. Maximum deflection is 93.551 millimeter and is greater than the required maximum deflection. It means strong load combination 1. In strong load combination 1, never happen during operation. And loading combination during normal operation equal with 1 heat load plus 1 live load simultaneously. Therefore, the maximum deflection as of the 41.925 millimeter. Drawing in the right side, below right side, that the red line is deflection limit and blue line is actual deflection limit. And this is the maximum deflection of the railway bridge we researched. Left side is drawing about the bridge capacity ratio. And based on this drawing, we collecting data to be accumulated in the dashboard design. Next. We discussed about the maximum stresses and natural frequency. In cases, we found that the maximum stress of numerical modeling is 100.4 megapascal. The best bending occurs in mode 4 with the natural frequency and mass participation of 4.162 Hz and 93.639%. The dynamic characteristic showed a typical values for the type of railway bridge structure. And then right side, we discussed about the component of structural railway bridge monitoring system. In this case, we found that the fact that the data transfer through the transfer instrument will enter the data interface and document control. Data result will appear on the reading dashboard for use by a stakeholder or policymaker. Accelerometer sensor is used to measure vibration on the bridge, and also accelerometer sensor is also used as an alternative of measuring the deflection on the bridge. In this case, also we use 3 types of accelerometer. We use 3 types of sensor like accelerometer, strain gauge, and also subsidence. And the largest deflection in the middle of the bridge span. So we place 3 items of sensor place. Next page. Concluding remarks that based on the analysis in above, that numerical model showed that the critical boundary conditions were determined by deflection, while the natural stresses and frequencies were within safe limits. Maximum deflection occurs at the center of the grider. Other than the grider center, the deflection is still very far from the maximum deflection. in terms of the surface load, deflection that occurs is still in safe condition, provided bracing frame are dimensionally upgraded. The railway bridge structure can be stated that the bridge structure is still safe under stress control because it is smaller than the allowable stress. The frequency to be reviewed in the frequency if is the frequency of the first bending of the structure, and the mass participation must be greater than 90%. The numerical analysis results shown that the first bending occurs in mode 4 with frequency and mass participation of 4.162 Hz and 93.639% respectively. Data from sensor sampling are collected by the acquisition instrument data and sent to the data processing center via instrument transfer, which is then used by automated expert system, which can be reached in the reading dashboard on the bridge structure. Yeah. Next. Thank you very much.
Okay, thank you, Dr. Dwi Agus Purnomo, for the nice presentation. And now I am open for the Q&A session. Any question from the floor?
Sorry, Dr. Dwi, Chinkang here. I want to ask if you have considered the temperature on your steel bridge for the rail track, because the temperature will affect the stress of the steel, right? Temperature drop and temperature raise.
Oh yeah. Oh yes. I mean, temperature of the steel is influence of this research. Yes. But we still now in the field. I mean, operate the instrument to obtain the data. How long for the temperature will influence in this study.
Okay. May I know how much you apply to the rail steel rail? Temperature raise how much? Temperature drop how much?
Berapa persen? Temperature berapa temperature? Berapa temperature? We default by software like that. Yeah.
Oh, actually, what I know is every country got every different temperature. Like ASEAN, we normally use about 37 max or 40 max. Like Europe, they will use highest or lowest. Correct?
Yeah. One more question, Mr. Ching?
Sorry, your project is at Indonesia, correct?
Yes.
Oh, okay. May I know how much you use? Because what I know, ASEAN country normally you use 37 max and drop 21 something, correct?
Okay. I mean, the dimension of the bridge, in this case, is 51.6 meter, and width is 4.45 meter, and height is 5 meter. This dimension of the bridge object.
Okay. Example. Now at Singapore, we use 27 as a normal temperature.
Yes.
Then when raise the time, they will plus 10 degree. So when raining coming, they will drop to 21. This is what Singapore apply. So I want to know that is it you also apply the same thing at your model?
Kita berapa temperature?
Actually,
This by
the temperature simulation or our software is about 30 degrees Celsius, and it adjusted to the condition of the Indonesian in day season, sir.
Okay, so you are using 30 30 as a normal temperature.
So that is 3, yeah.
Then raise
Degree
10
Celsius.
Celsius, yeah.
10 degree, 5 degree.
Yes.
So drop. Because raining that time your temperature drop, correct?
Yeah, because we adjusted to the South Lampung conditions in day season.
So how much you use you apply in your model? Drop.
Actually, in software, we only input about the dimensions of the steel, and also about the Poisson ratio, and also about the modulus elasticities and the temperature and G coefficients. It's default by the SAP software, SAP 2000 software.
Sorry, may I know which software you use?
Pardon me?
Atomic. Okay. Okay, can. Thanks.
Okay, thank you.
Okay, thank you, Jing Wei.
There is one more question from Dr. Shanmugaseka. Okay, the question is level 1 has to be maintained. It goes more to be stamped and maintain the track geometry. Is it?
Yeah, all the way, for the good track, maybe they can go to from 1 to 2 mean the deterioration. Level 1 and level 2, they have to maintain it. Because the sign shows that is a deterioration rate. Is
Okay, any answers from
for the level 1 ride index, when the track recording machine applying, because of the jerk, the acceleration limit, they have to maintain 1. If there is a track geometry, this a difference is there. If it goes, I think 2 until the 2 can allow. If it's more than 2, it is not possible because it is going to the not possible limit like that. Within the period, they have to send the tamping machine and they have to regularize a thing.
Yes, I mean the deterioration due to the bridge is because of we obtain the bridge with old type more than 30 years old. So many deterioration occurs in this bridge. So many activities we protect. We use the the inspection, real inspection by man, also inspection by the software, like we now mix in software operating system of the bridge. This is a condition. It is enough for your question, Mr. Sanmuga?
Hello?
Please more question, please more detail of the question.
Is in the rating, is it?
Yes.
Yeah, but you see from my table, the ride index, until 2.5, we can allow it. It's in nearly good condition. After 2.5, it gives me the track geometry is something wrong there. That means the standard deviation is exceeding. So they cannot allow to go 3. The track condition, it is not good.
Okay. Jadi kalau ada itu pembatasan gimana?
Is it okay?
Yes. So that's why in this object we we put the certain instrument. If the bridge is not enough to be passed through by the train, then we put some instrument lowering system before the train enter the bridge.
Oh, are you talking? I am not talking in the bridge. Hello?
Yes. Once more.
No, I am Shanmuga Shekhar from the track, the one I present for the track.
Yes.
You are talking to me or to the presenter for the bridge one?
Kita bahas structure bukan tadi.
Oh yeah, yeah, okay.
I'm sorry, sir. Actually, we discussed in this research about the structure analysis, not in the track geometry. It means not discuss about the level indexer.
In this study, yeah, we start only in initial design, like UV design, not in detailed structure like track or also geometric, because we focus in the bridge itself, in the stability of structure like that.
Okay, is that enough, Dr. Shanmuga? The answer?
Yes. Doctor, my thing is only not in the bridge. I am taking in the general at the embankment condition, not at the structure. My model is only at the ground, at grade, not at the structure, not at the bridge portion. You see, when you go to the track in the bridge, the bridge, it will be a rigid body. It is not my model is not valid for that.
Okay. It means you solve the model of the bridge with obtained with my supporting research like that.
Sorry, doctor, my model is not representing the bridge.
Yeah.
My model is in the embankment. That is a subgrade soil. Over that is a ballast, sub-ballast, and the sleeper and the rail. That is come to the embankment.
Oh, I'm sorry, sir. Maybe I want to clear these communications. You want to answer our questions, right?
You are
In the chat column.
chat column. You see the one chat column is yes, I am answering.
Okay, thank you, sir. Thank you, Prof. Shanmuga.
Okay. Welcome.
Okay, clear.
Okay,
Yes.
Okay, thank you very much, Dr. Dwi Agus Purnomo and Dr. Shanmugam for the question. Okay, thank you very much. Okay, now we move to the fourth presentation. I would like to invite Dr. Muhammad Khairul Kamarudin from School of Civil Engineering, University Technology Mara, Shah Alam, Malaysia, with his topic entitled Numerical Analysis of Crack Propagation in Tubular Glass Column. Please welcome Dr. Muhammad Khairul.
All right, okay, thank you. Let me just share my slide first. All right, this slide is visible.
Visible.
Yeah, thank you very much. All right. Okay, Assalamualaikum and good morning. Thank you very much to the Madam Chairperson and all the presenters of this session, Room F, Structural Engineering, and also the attendees of GCOMSE 2021. I'm so glad to be able to present our research finding that has been conducted by my fellow student, master student, Ahmad Walid, in looking into this quite far off from what we had the existing material in construction, which is glass. But structural glass is quite prominent among the construction in Europe as well as in the east side of the world, which is in China. So basically, we this perspective in identifying the structural performance of glass, specifically, particularly in looking at the structural glass column. So we are in the team. I have my student Ahmad Walid, me myself, Muhammad Karul Kamaruddin, a senior lecturer from UiTM Shah Alam, as well as my counterpart collaborator, Dr. Mustafa Sani Muhammad Yusuf, senior lecturer in USM Malaysia. And today I'm going to talk about the topic numerical analysis of crack propagation in tubular glass column. So as I mentioned just now, particularly glass in Europe, and because of the aesthetic value as well as the way the architecture look on the vision of the building itself, because glass have this intrinsic behavior as transparency. So transparency, people, they like to ensure that the term achieve economical building, which they said that when we have the transparent glass wall, we don't need the usage of the electricity that much. But there's a quite a debate at the world platform, where because we are using a glass, it allows light as well as the heat from outside, and that comes to the certain cases where an advancement in glass technology is proposed. For example, using double glazing, and now they have this technology of having a dynamic glass wall, where the glass wall accommodate the IoT system. When the sun rises, the glass wall can change the intensity of what we call that. Let's say when we have it in the car, we need the tint value to the tint layer to ensure that a very limited of light comes in as a shading. So that is the technology that we have now. But particularly when we talk about glass column, this has been as in existing building, as you can see from these pictures, two pictures from the right. We have this glass column in one of the headquarters building in Denmark, and one in the France. If you can see clearly, they use the cruciform section of glass column, which is a panel of two glasses combined together in a cruciform section to sustain or to resist the load distribution in the building. So basically, this structural glass has been there, and we at the Southeast Asian, we yet to have the intensity of structural glass building, but we can see from the whole lots of the hoteliers, they have this glass wall, curtain wall as a eye catcher for the building itself. So in this case, this research, technically, actually, we are coming from the extension work from the work that we have done into 2018, where a series of experimental work of a glass hollow tube with certain dimension. We tested under compression analysis modeling, where we use the abacus to look upon the usage of brittle cracking material model that is available in the abacus software. So from this idea, we wanted to look upon this crack propagation in the tubular glass column, as well as to carry out some parametric study in the different dimensions to look upon the effect of different slenderness ratio that can contribute to the glass column integrity. So from these two objectives, we're going to conduct it using the abacus platform, brittle cracking material model. So as a significant contribution, we wanted to check when we conduct this analysis, we're going to find we would like to extend further the investigation if we can define parameter for the structural glass, which because currently we yet apparently it was the first step for us to actually to ensure the result is reliable. Most of the modular sensitivity analysis model, so that from there, when we use a mesh density from coarser to finer, from there we're going to decide what sort of mesh refinement that to be used to achieve the objective. So from there, which technically the most important configuration that need to be included in the analysis is to ensure that we had the parameters, the crack after the collapse happened and so on. So that parameters is very important to conduct this brittle cracking model in abacus. So basically, we have kind of 6 different dimensions with the same height, with different outer diameter and inner diameter, and also the wall thickness of the glass tube. When we conduct this analysis, the first part, when we look upon results, is in terms of the failure mechanism. We managed to identify 2 different characteristics for the failure mechanism. When we have this quite a smallest or a lower slenderness ratio, we expect the glass column to fail under. But when we have a slenderness ratio more than 40, the impact or the failure that predicted is in terms of a buckling failure. So this case is comparable to what we had from the experimental work previously, as the same constant 40 slenderness ratio is a benchmark to give us result whether the glass column is failed, either buckling or crushing. Experimental work. I have this is the size of 24 diameters glass tube with a 2.5 wall thickness. The glass is expected to buckle, and then when we conduct the analysis, it's sort of at the midsection of the columns, and we tend to see this as a comparable kind of result between the FE as well as to the experimental work. Same goes to what we had in here. This picture shows the post failure, where only the remaining pieces of the glass remains at the end section, whereby when we had in the FEA we had these multiple kind of breaking. And when we look upon this load and axial displacement, we plotted this graph from the experimental work with different same T1, T2, T3, T4 are from the same dimension. It's just that we have 4. So we plotted the risk method available in the abacus, which is this risk method has been conducted in terms of capturing the post-buckling behavior of the structure. But when we have that, the result from the risk method is quite far off from what we had from the experimental work. It tends to overestimate, and as well as the stiffness is quite far off from what we had. So for this paper, we wanted to enhance the exploration in the FE by using this brittle cracking method, and we managed to capture quite a significant result with a quite apparent gradient of stiffness of the glass. It's just that the result that we got estimate to compare to what we had from the experimental work. But as a justification here, we do understand that for glass specimen, we cannot take the result as an average because of each glass. Even so, they are having a same kind of geometrical dimension. The glass has a unique character that cannot be quantified, which is each glass has what we call as a initial face crack on the surface of the glass. So that initial crack cannot be quantified yet. We are now trying to come up with a methodology on how we can quantify the initial crack on the surface of the glass, which is 3/5 flaws. So we wanted to have that in our mind to actually conduct this analysis further. But somehow we tend to share this information that we managed by using the brittle cracking method. We managed to capture quite an agreement kind of result, a correlated result to compare to the one experimental work. So in this table, we shows that, as what I mentioned just now, when we have variations of salience ratio, okay, we managed to capture a significant type of failure mechanism that mark how the glass column will collapse, is either in terms of crushing and buckling. So in this case, we still managed to secure that this 40 salience ratio should be the benchmark of how to identify or to distinguish of how a glass column should collapse. But this one shall not stop here. This information we're going to continue in plotting the slenderness, the buckling curve of the column. So we, at the end, we managed to get a very steel that can be the point of reference for the designer to be able to design the structural glass. So in this way, we had in our mind of the Fortis linear ratio as a classification to identify whether the glass is a slender or short column, as well as the usage of the brittle cracking method in the abacus that is very useful for the researcher to actually embark into looking into the crack propagation mechanism of the structural glass specifically. And these are the reference, and for that, thank you very much for listening.
Okay, thank you, Dr. Muhammad Khairul from UITM for the presentation. Okay, now I open for the Q&A session.
Yes, please.
Is there any question from the floor?
Yeah. I have one.
Yeah.
Okay, thank you, to chairperson. So, Dr. Muhammad Khairul, is it?
Yes.
Yeah.
Yes.
Yeah. Thanks for your clear presentation. That is an interesting idea. It's good idea. So, however, philosophically, we have to consider where we live. So we are not in Europe, isn't it?
Yeah.
As we know that in South Asia, the sun shine all year round.
Yeah.
If building use a lot of glass, of course, the problem will come as rising temperature, glare, and also the important thing in Indonesia, of course, is earthquake load must be taken into account in this area.
Yeah.
So whether in your software calculation take into account repeated horizontal, or are you calculation about recycle load? Because I think axial load is quite significant with lateral load for material glass. Yeah, I think that's it. Thank you.
Thank you, Dr. Joseph, for the where we live in the area that the sun is quite intense. As I mentioned just now, the technology of having this dynamic glass wall can be the solution. That is quite a prominent technology, quite new technology. It has been in the industry, I think last year, they just got to, we have this conference of glass technology, in the World Glass Technology Conference. They have one of the contributor or manufacturer of glass managed to come up with this solution of dynamic glass, incorporate with the IoT system. So that can be the solution. But I agree with you. We still far off. Actually, this material is quite far off from what we had in the existing material. It's just that as a structural engineer, we need to fit to what architecture has proposed in the building design, because we can't rely on how they look upon the structure system, the structure engineer. The structural engineer need to come up with some provisions so that they know that the design can be done. But in referring to your questions, we are yet to take into account the cycle loading or the earthquake loading. Hence, because of now our idea is just to check static load, because glass, the idea of to have glass to carry as a load bearing element is there. It's just that there's some concerns need to be highlighted, and in a way that our research we're trying to pursue that direction. But if this intensity of having the static load is quite give a promising that the glass can be designed accurately, and maybe after that we're going to look upon the effect of having the earthquake load or a cyclic load as the impact to the structural system of the glass. Am I answering your question? I cannot hear you. Yeah, on mute. Yeah. You are still on mute, doctor. Dr. Joseph, you are still on mute.
Dr. Joseph? Dr. Joseph?
Yeah.
Okay.
Oh yeah.
We're
Okay,
missing
okay.
we're missing
Sorry.
we're missing your words actually, but we can see that you are
Oh yeah.
you are talking
Sorry.
just now. All right.
Sorry. Yeah. I think this is begin to something a good idea.
Yeah.
Maybe you can count about the cyclic loads
Yeah.
or lateral load for the glass, because the glass is very high for the compression, but
Yeah.
not good for the
Yeah, very low
tension.
intention.
Okay,
Yeah.
yeah.
Thank you
Okay,
for your
good.
sense there.
Thank you very much, Dr. Muhammad Hairul.
Thank you. Yes, Doctor. Said.
Thank you very much, Dr. Muhammad Khairul, for nice presentation.
Thank you.
Just my question is there any research about the open tubular glass column?
Oh, okay.
And about the effect of the crack propagation on the stress intensity?
You're asking about, is there any research on tubular glass column before?
Yes, about the open tubular glass column.
Open tubular glass column. I believe. Okay. May I know what sort of difference when we have an open and closed tubular glass column? What is the concern there?
Maybe needs any opening on the column or anything.
Oh yes, okay. If you are talking about that, we conducted a experimental work. Obviously, the glass column stand and on its own is open. It's just that we put the what we call that, the load cell, the load platen, and then we just crush it under the compression test. That's how we conducted our experimental work before, doctor.
Oh, and how about the stress intensity, that area?
Oh, the stress intensity. All right. Okay. The stress, basically, when we have that a short column, it's the stress.
Oh.
That is where the cracks start to propagate, and then the column just go bang. But when we have a slender kind of column, we manage to witness the glass has have a buckling kind of shape, and then it start to crack in the midsection, and then it go bang. So that is how the stress intensity coming through from a different slender and short kind of column.
Okay. Thank you very much.
Thanks.
Okay, thank you, Dr. Syed.
You're
Is there any
welcome.
more questions? Is there any more questions? Okay, from Dr.
All right.
Zainul
Yes. Yes, doctor.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Zainul Rizwan, and basically I have one question, because just now you have presented about the crushing behavior of the column using in which that you are numerically obtained using abacus.
Yeah.
I think I'm really interesting to understand how the crushing behavior happen on that particular structure. So during the crushings of the column, so the fracture or the crack propagation and fracturing that happen on the column. So by using a brittle cracking method in abacus, maybe Dr. Muhammad Khairul can actually share with us what the so-called parameters and factor that govern the crushing or fracturing of the glass structure in abacus. That is my question. Thank you.
Okay, thank you very much for the question. Right. Basically, we're going to input the first of the stress strain glass result that we had from the experimental work. That will be the first basic information that we need to include in the abacus, because that's going to actually follow through the trend or the pattern of the stress the experimental work. They need to us to actually give input, extra input on the brittle cracking properties as well as brittle shear and failure properties. Okay, basically, doctor, those values we haven't got that value from our experimental work. Okay, we do have it. We do have the brittle cracking property, which is the direct stress after cracking and direct cracking strain that can be gotten easily from the experimental work. It's just that one value, which is brittle shear and failure properties, on the shear retention factor and crack opening strain, we do not have that value specifically from what we have conducted from the experimental work. It's just that we just use the default value that has been available in the abacus, because from the abacus manual they mentioned that if some of the values are absent, we can just use the default value, and then we run the analysis, and we sort of having that kind of result. But I believe this not stop here. We wanted to look at this method further so that we can have quite a promising kind of result in terms of the load displacement behavior as well as the failure mechanism, doctor. I hope that's answering your question.
Yep, thank you very much. By the way, I have one more question.
Yes, please.
Because the crushing behavior very interesting subject matter in structural engineering. Okay, because the crushing, I believe the crushing happened very sudden, right? Unlike many other types of the structure, concrete or steel that experience so-called a stable crack propagation, I believe that the glass experience sudden crushing. So in this case, because when we considering the sudden behavior under loading, so I believe the stress strain curve that represent the glass material maybe not, I think, a very normal condition that we basically adopt for
it's just a linear kind of gradient, doctor. The stress strain, we got a linear kind of gradient because glass does not possess any ductility whatsoever.
Okay, thank you very much.
All right, thank you.
Okay, thank you, Dr. Zaino. If there is any more question? No more? Okay. So if there is no more questions, so I would like to thank to Dr. Muhammad Khairul for the nice presentation.
Thank you very much, Madam Chairperson.
Thank you, welcome. Okay, now we move to our next presentation. I would like to invite Tuan Nurhayati Tuanci from Jamilus Research Center, University of Malaysia, Bukit Raja, with his slide entitled Prediction of Traction Vibration Effect on Heritage Building at Muar Johor, Malaysia. Please welcome.
Okay, thank you very much. Okay, thank you very much, Dr. Masni. Okay, I'm sharing the file, please. Okay, can anyone see it?
Yeah.
Okay, thank you very much, Mrs. Chairman, Dr. Masnia Majid. Okay, so now it's my turn to present the paper for GCOMSE 2021 today. Okay, so my paper is the title is the prediction of traffic vibration effect on heritage building at Muar Johor, Malaysia. So this is the study that have been made investigated by my ex-students and within Jamila Research Center and also the Research Soft Soil Center. Okay, so the presentation outline is the first one I will go through for the introduction, and then I will explain the generic vibration criteria that we use and the site measurement using dynamics, and then final element modeling by using ANSYS, and also the detailed analysis for the vibration criteria analysis by using results and model V, and also the last one is the conclusion. Okay, so as an introduction, as we know that vibration is one of the frequent issues which lead to the failure of the buildings. Okay, normally, yes, it's not moving. Okay, so I will use like a normal. Yes, I already share. Is it can see or not? Okay, let me. Okay, is it moving or not? Is it okay? Maybe I cannot in the presentation mode, but in just in PowerPoint mode. Is it okay? It's moving now or not? Okay. Is it okay now? Okay. So can I move on? Okay. So as an introduction, so the traffic-induced vibration has increased significantly since the population image also increased year by year. So thus the vibration produced by road traffic needs to be focused it has a possibility to contribute a long-term adverse effect on historic structures. So traffic vibration is often caused by heavy vehicles that drive at a relatively high speed and contact with uneven road surface. So the objective for this study is the first one is to predict the effect of vibration, traffic vibration on the heritage building to obtain the natural frequency and mode shape. And finally, we need to compare the vibration effect with the vibration criteria analysis by using results and model V. Okay, so this is the building that as our case study, which is the telecom building, which is very old building. It's an abandoned building, and here she is my ex-student. Okay, so this is the generic vibration criteria that we are used for the comparison in this vibration as a tool guide. So this is a total of 5 types of criterion curve, which are curve consists of VCA to VCE. So this one is VCA to VCE as a model. Okay, the are taken from the form of a set of a 1/3 octave band velocity spectra together with ISO guidelines. Okay, so this is the details of the description for this curve for description of use. What is VCA and what is VCE? So this is the table that we are using for the comparison method. Okay, as for the site measurement, actually we're supposed to make with a proper equipment, but it's sadly because our equipment is already have something not quite promising, so we need to make a different alternative using a MCO happen. So we cannot go to the for the proper equipment. So we managed to use a iDynamics system, which is a mobile application which developed by University of Kaiserslautern, Germany, was used for the field testing. So the field testing was performed in order to obtain traffic-induced vibration signal which happened around the building. Okay, so this step was very important as the data obtained and input analysis has directly reflected the situation that occurs in the reality. Okay, so for site measurement, we use a Lenovo P70 smartphone. So 2 points were chosen for the field testing. The first one was placed at the ground floor, considered at point 1, and the second one is near the main road of the building. So a flat floor surface was chosen to place the smartphone, and this is to ensure that the traffic-induced vibration can be directly detected by smartphone without any other disturbances. Okay, so this picture shows this is the point 1 that we put near the column here, and the second one, the point 2, is near the fence at the end of the area of the building. So here, me and my students during the site measurement session. Okay, so the result that we so this here is the picture shows the point 1 and the point 2, and the main road is here. So the traffic flow is actually at this road. So when the traffic is passed by along this road, so we captured the vibration signals via the smartphone. So the point 1 and the point 2, so here is the results that we obtained. For point 1 is about 0.150 meter per second squared, and for the point 2 is like a similar. Okay, so after we got the vibration signal from the site measurement, and the second phase, what we need to do is we need to model the real building into the ANSYS via the finite element modeling by using modal analysis and also transient analysis. So this is the script, the common method that we use for the modeling. And here this is the main building. Okay, and then finally in ANSYS we got this building is like this. Okay, so the first mode for model analysis, we obtained the first mode is 2.57 Hz. This is for the fourth mode is 3.89 Hz. So here you can see the building, how it looks like in ANSYS software. Okay, so here is the results that we obtained from the transient analysis, and then we compare. So this one is input from the iDynamics application smartphone, and this one we have output from ANSYS. So we got like a 0 meter per second. So here, why is 0? Because the acceleration is too small when we model in the ANSYS. Okay, so after the data from the ANSYS, we need to transfer to another software, which is MATLAB software, to model the vibration filter analysis, which is, we call that VSAX tool, which is vibration serviceability, to see the vibration response, because we want to compare with the Gordon guideline that I show you before. Okay, so for vibration input for point 1, vibration response, so we got from the VSAX is as you can see, it's all brown, which is it shows that it comes into VCE. Same goes to the point 2 as well. It's also all brown and it falls into VCE. So when we compare to the Gordon table, so VCE is the description of VCE is like a difficult criterion to achieve in the most instances, assumed to be adequate for the most demanding of sensitive systems, including long path, laser-based, small target system, and other systems requiring extraordinary dynamic stability. So the meaning is what's that mean is VCE is really small. The vibration signal is really small until we got the all the results that we obtained is falls into VCE. So another tools that we check is same. It goes in same in the MATLAB as well, but we call it modal V. So in modal V, we can plot point 1 and point 2, the vibration signal. So the time history is like this. So this one is showing that it's like there is no result, which there is no result, but it shows that 0 is like a really the vibration signal is really small, so it cannot capture the time history for the exact one because it's really small. Okay, so from there, so the conclusion that can be made from this investigation is, okay, the first one is the natural frequency of the building is acceptable as the frequency of the fundamental mode shape, which is mode 1, is 2.57 Hz, and falls below the range as stated in the ISO base curve. So the output acceleration obtained from the transient analysis was 0 millimeter second. This result indicates that traffic vibration which acts onto the whole building is negligible. Okay, so for the vibration pattern analysis, the level of vibration fell on VCE, which is the lowest level of GVC plot implemented by Gordon guidelines. So this has shown that the traffic vibration, induced vibration, does not show any significant effect on that building. So meaning that the traffic flow near the building doesn't affect that particular building. So therefore, it can be concluded that the whole building of Telecom Mall was not affected by the traffic vibration that occurs around the building. So I made a recommendation here as well. So actually, for the to get the better results, actually the accelerometer is recommended to be used to determine the traffic induced vibration in the future. So in obtain to the vibration signal accurately compared to the mobile applications. So further checking needs to be carried out to determine the accuracy of the vibration measurement using mobile applications. So the third one is the road conditions, types of vehicle passings, and the distance from the main road to the building are also important factors to be included in the future study as well. And the last one, the type of soil around the building should also be taken into consideration as the propagation of vibrational waves will be affected by the types of soil. So the last slide is the reference that we already used in this paper. And with that, thank you very much for listening. So thank you to everyone.
Okay, thank you, Madam Puan Hayati, for the nice presentation.
Thank you.
Okay, now I open for the Q&A session. Any question from the participant? Any question? Okay, if there is no question, I would like to thank again to Madam Puan Hayati for the presentation.
Thank you very much, Dr. Masni.
Thank you, welcome. Okay, let us move to the next presentation. I would like to call upon Ms. Nur Anis Najwa Abdul Muttalib from Structural Dynamics and Computational Engineering Focus Group, UTHM. The slide entitled Numerical Simulation of Modified Rubberized Concrete Block Under Impact Loads. Okay, please welcome Ms. Nur Anis Najwa.
All right. Okay, thank you to our chairperson, Dr. Masni. Okay, Assalamualaikum warahmatullahi wabarakatuh. Can all of you see my slide? Can?
Yes, please.
Okay.
Yes.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anis Najwa binti Abdul Muttalib, and today I would like to present a topic of numerical simulations of modified rubberized concrete block under impact loads. So before I start my presentation, I would like to show the outline of these presentations, which I will start with introductions and then go further with the numerical modeling. and then material properties of model, result and discussion, and lastly, conclusions. So for the introduction, I would like to repeat again the topic, which is numerical simulations of modified rubberized concrete block under impact loads, which this is all about the rubberized concrete. As we know, there are a problem which is about 1 billion waste tire are produced worldwide annually. And the tire, as we know, is a waste that can cause air pollution too. And the stockpile tires actually tends to create a health problems, which is a breeding of mosquito and rodents, which can cause dengue and leptospirosis. On the other hand, rubber can help to increase the energy absorptions. Although it can be a waste, but it still keep on being a good term of energy absorptions of a concrete. And on the other hand too, a concrete road barrier with a high capacity energy absorption can reduce or minimize impact force from uncontrolled vehicle to protect the passenger in the car. So here, this study would like to use sand as use rubber as a partial replacement of sand, so that can produce a rubberized concrete, which is good in terms of energy absorptions, and at the same time can reduce the productions of waste and also stockpile tire. So this is the numerical modeling that has been used, which the development of numerical procedure using FEM Abacus to effectively simulate modified rubberized concrete under impact loads. So the numerical modeling that has been used is Abacus software, which this figure shows clearly the sample, which is down here is a concrete block, which the concrete block, the normal one is a control is 0% rubber and also 0% of rice husk ash. And then keep on with the increasing of the percentage of the rubber. So the size of the specimens is about 300 times 300 times 200 mm. And up here is a steel projectile, which the steel projectile is actually is a projectile that is free falling about 1.6 meter high, which the size is about diameter 40 mm and the length is 800 mm, which the weight is about 80 kg as you free falling test. And then the 8-node brick continuum element were created for this modified rubberized concrete for this Abacus software. And the velocity is about 4 meters per second as due to the experimental. And then for the software, it keep on increasing about 5 meters per second and 6 meters per second. And actually the boundary condition assigned at the bottom part of the concrete block, so that when free falling of the steel projectile, the concrete block is not moved. And so it targeted center of the concrete block. So this is some of the material properties of the model, which the rubberized concrete elements adopting 3 different material descriptions, which the elements of Abacus about DP, MDPC, and CDP, which DP is a Drucker-Prager, MDPC is a modified Drucker-Prager CAD, and CDP is concrete damage plasticity. So here we would like to use 3 of these and find out which one is the suitable one to the applicable for the rubberized concrete. So this is the material properties of the rubberized concrete, which this is we can get from the experimental work, which the rice husk ash and also crumb rubber for the control is 0%, and the rice husk ash after that is 10%, which this is from the previous study. It shows that 10% of rice husk ash is actually the optimum percentage, which can help to cater the problem of the drop of rubber, since when we partially replace rubber in a sand, actually it can cause drop toward the compressive strength. And RHA also is partially replaced for cement, which is about 10% replaced by mass. And for the mass density, compression strength, tensile strength, Young modulus, and Poisson ratio, all of this we get from the experimental data. And then go on with the parameter of DP, MDPC, and also CDP, which all of this parameter, this study got from the previous studies. All of the eccentricity, material angle, and also the material properties of the steel projectile also got from the previous studies. So this is the result and also the discussions. First of all, this study used a mesh density sensitivity, which the mesh density sensitivity is quite important, which it aim to ensure that the FEM results is more accurate, which is this one is depends on the global size, which the smallest the global size, actually it can produce a more accurate result. So here, this study used some of the size of the mesh density, and here is the total element, penetration depth, and also energy absorptions that produce. Okay, and from here, we see that 13 is the most good one, but compared with 13 and 15, actually it's not too much difference. And if we use the size of the mesh is too small, actually it will cause longer time to process the data. So I found that 15 is the most good one for the mesh density that need to be used so that we can get a accurate result. So this is the comparison between three method descriptions, which the CDP and also MDPC with the experimental work. So here we would like to see whether the CDP, DP, or the MDPC is compared with experimental, which one is more near with the experimental work. So here we can see that CDP, which is concrete damage plasticity, is much more closely with the result of the experimental, which is only about the percentage difference about 8.80. So to be clear, here is the figure and also the graph and also the line graph and also bar graph. It shows the penetration depth versus the percentage and also energy absorptions versus the crumb rubber. It shows that compared with the experimental CDP, DP, and also MDPC, CDP concrete damage experimental here. Okay. Concrete. Here clearly shows that compared with experimental result of impact test with the finite element model result, it shows it not too different. It can be observed that the general outline of the damage after the impact of the numerical model and experimental are in a closely agreement, which is mean that this mean that for the Aggregate software and the experimentals is not too much difference. So we can use FEM to model the impact test experiment. So we can reduce cost and we can reduce time to do the experimental work. So for the rubberized concrete under difference impact, here is the difference velocity that has been used and also the energy absorptions. The higher the velocity, as it will cause the higher the energy absorptions result. And what most interesting here, the higher the percentage of the rubber replaced, it will cause the higher result of energy absorptions. This is quite interesting because shows that rubber is good in terms of energy absorption, so it can be used as a concrete barrier. So therefore, more energy transfer to the rubberized concrete for the energy absorptions. So for the conclusions, it shows that the CDP, concrete damage plasticity model, produced a high accurate result of FEAN modeling compared with DP and also MDPC. It clearly showed at the previous slide that the concrete damage plasticity is good one result, which is more closely with the result of the experimental. And the failure profile of the rubberized concrete in the model is almost similar to the experimental observations. So it's quite good. And then for the crown rubber in concrete, it actually generates a good result for energy absorptions. And therefore, the elastic behavior of a concrete increased by the additions of rubber to resist more impact, which means absorb more energy. So to highlight the conclusions here, it shows that to model the rubberized concrete, concrete damage plasticity model is the one that is more accurate, not to say accurate, but more good. And then for the replacements of rubber actually help a lot to give a good result of energy absorptions compared with the normal concrete, which does not have a rubber. And so it can help to first reduce the waste, the productions of waste of stockpile tire. And second, actually, it can help to give a good energy absorption, which can reduce the impact, can reduce the damage of the vehicle during the accident's occurrence. Okay, that's all from me. Thank you.
Okay, thank you to Miss Nur Anis Najwa for the nice presentation. Now I would like to open the Q&A session. Is there any question from the participant?
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Ini Anis Najwa, apa khabar? Sihat?
Sihat, alhamdulillah.
Okay. So basically, based on what you have been presented just now, this kind of design of rubber crumb concrete technology. So we can apply this kind of technology on which kind of structure? Could you explain more? Maybe probably this kind of technology has been implemented in Malaysia or so on. So if you can describe more, thank you.
Actually, from what I see the previous study, it's not they not do more further about this study for the concrete barrier. So I think this type of rubberized concrete is applicable and good enough for a concrete barrier to increase the to give good result of the energy absorptions and reduce the impact for the car, which reduce the damage and also fatality. Is that answer your question, Dr. Fahmi?
Okay, so meaning that is more to the transportation, isn't it? So more to the highway applications. So do they try to in terms of building applications?
Yeah, maybe in terms of to absorb the sound, that one is applicable for rubberized concrete.
All right, thank you.
Okay, thank you, Dr. Ahmad Fahmi. Any more question? Okay, Dr. Zainal Rizwan.
Okay, Assalamualaikum. So to the presenter, I have one question regarding your finite element modeling. Because you are using the rubber, right? Rubber crumb. We is degrade long term. So the elastic properties or other kinds of the mechanical properties may slightly degraded or reduce from the initial condition. So in your finite element, how you consider the degradations of the material properties in your material model or in your quantity flow? You are using the Drucker-Prager, right? So how this degradations of the material properties is considered in the finite element? So this is my question. Thank you.
So the degradation is based. If you see the slide, actually, there I have key in the previously experimental data of the compressive and also the tensile. So we consider the drop of the strength at there. So there the properties shows the dropping of the compressive and also the tensile based on the behavior of the concrete itself.
Okay. Okay, is there any more question? No more question? Okay, if there is no more questions, I would like to thank again to Ms. Anis Najwa for the presentation.
Thank you.
Welcome. Okay, now we move to the last presentation of the session. We'd like to call upon Mr. Chia Wing Hong from Structural Dynamics and Computational Engineering Focus Group, UTHM, with his slide entitled Effects of Section Properties on Structural Behavior and Failure Mode of Build-Up TFS Column. Please welcome Mr. Chia Wing Hong.
Hi, everyone can hear me?
Yes, I can hear you.
Okay, so good afternoon, everyone. My name is Chia Wing Hong, and I'm going to present about my title. Everyone can see the slide, right? I had shared slideshow. Okay, so I'll proceed. So the title of this paper is Numerical Modeling of Build-Up CFS Column, which specifies the effect of section properties on structural behavior and failure mode. So these are the co-authors. Okay, so this is the outline of my presentation, initiated with intro and go to numerical modeling and ended with the conclusion and reference. So the introduction. So BRCF column is a type of co-form steel structure that can be classified as a industrialized building system (IBS), and normally it is combined of a vertical member, batten lacing, and a connector. So this type of column is suitable for the construction of building at the site with difficulty in accessibility, such as building in the rural area. And for CFS, it's relatively lightweight and easy to fabricate and provide efficient installation. So nowadays, a BRCFS column has become popular due to its strength to weight ratio. Okay, so basically this type of BRCFS column is actually applied at a dive school. And for your guys' information, dive school is actually under the full scheme of the Ministry of Education to provide the education facilities in the rural area. So basically, the research is to study about the BRCFS column that support the dive school, such as you can see in the SK Pulau Rusa Pekan Pahang, the column, and as well as the SK Lenjang Lipis Pahang, to support the structure. So our BRCFS column, the design is exactly same as the dive school BRCFS column. And typically, the BRCFS column can be designed using the lip angle or channel to form the closed section. And this, it can be seen that actually from the figure below is actually the top part it consists of the lip channel as well as the closed section angle. And for the problem statement, the design of the BRCFS column actually follows the clause 6.4 in EC3 and it is as similar as the hot roll steel members. So the major issues arise from the design of BRCFS column in terms of strength and stability towards the compression force. So BRCFS column is prone to buckling, but it can be resisted using the batten. However, the batten, the using of batten depends on the design of the column. And ECT3 has not specified the equation to determine a critical load. So according to clause 6.4 in EC3, it only specifies about the design shear force, VED, and also the design action, the NED. However, it does not specify about the design critical load. And for previous works, it only for build up CFS column, it only focus on the lip angle channel and instead of the closed section channel. So literally, the previous works does not really focus on the closed section, which is similar as this design of CFS column in this research. And lastly, there is no compromise in the serviceability of a build up CFS column. So these are objective of this research. The first objective is to stimulate the build-up CFS column subjected to the compression force using the program called ValSim. And the main design of the CFS column is actually a closed section. And the second objective is to analyze the force displacement curve of the build-up CFS column for different section properties, namely the thickness of the CFS column as well as the size. And the last one is to evaluate the effects of section properties on the ultimate strength displacement as well as the failure mode of the build-up CFS column. So for the design and specifications of the build-up CFS column, it actually consists of the SHS as the vertical member, as you can see in this schematic design, and metal plate as a stiffener, and the rivet as the connector. So basically, the size of the SHS will be comprised of 3 different size: 19 mm times 92 mm, 25 mm times 25 mm, and 32 mm times 32 mm. And this the SHS will be used is using the character strength of the use strength 350 megapascal and ultimate strength 420 megapascal. And it will be using 5 different thickness as stated below. However, we shall be noticed that the thickness of the co-form steel shall not exceed 3 mm. And these are the schematic design of the CFS column. And the length is about 125, and metal plate thickness is about 1 mm thickness. So for this numerical modeling actually is based on the previous experiment study conducted by student in UTHM. So the experiment study on the BRCF column will be subjected to compression force and conducted using the universal testing machine. And the compression force was applied incrementally at the speed rate of 4.17 kilonewton per minute until the appearance of yielding or total collapse. So we were initiated with the specimens preparation, which is the fabrication of the BOF-CFS column, and go through the compression test using the universal testing machine, and ended up with when the specimens fail. And next we'll enter the numerical modeling. And the numerical modeling will be conducted using the software so-called ValSim. And this finite element modeling program actually requires the definition of the geometry, material model, loading, constraint, and the contact surface. So the BOF-CFS column was modeled in the three-dimensional and discretized using the tetrahedral elements with the unstructured mesh. So I would like to draw the attention that actually for the mesh size, it doesn't use the mesh sensitivity test. This is because that for ValSim, the mesh size is actually defined by is automatically defined and using the adaptive refinement method. So the size of the mesh is around 10 mm to 50 mm. So this is why the no mesh sensitivity analysis is required. So next we'll enter about to define the mechanical properties and the hardening properties of our model. So for the mechanical properties, the density and Young modulus, Poisson ratio, shear modulus, yield strength, and ultimate strength is actually based on the previous experimental study. So for the hardening properties, the plastic strain and the true stress is actually obtained from also the previous experimental study. This is because that we are during this pandemic, we are unable to conduct the tensile test for the cold-form steel. So we're using the previous experiment study data that could be represent the cold-form steel behavior. So for an incremental concentrated load was imposed in a downward direction towards the top part of the square hollow section, and this loading was applied at the top part for 1 second with the 15 substep. And it signifies that the compression force produced by the universal testing machine with the speed rate of 4.17 kilonewton per minute. And constraint is specifically using to represent the support and control the translational of the BOF-CFS column. For the bottom half of the BOF-CFS column, it was defined as a fixed support, and this allowed that the constraint become true in all x, y, z directions. This restricts the horizontal and vertical movement as well as induce the reaction force. So on the other hand, the top part of the BOF-CFS column was free. And the bond mechanism between the rivet and steel plate to HHS must be provided using the contact surface. So in this numerical modeling, perfect bonded was employed as the contact surface, and is requiring the definition of the master and target geometries for the BOF-CFS column. Therefore, the body of the rivet was selected as the master geometries, while the interface of steel plate to the HHS was defined as the target geometries. So in this condition, no sliding and separation was allowed between the geometries. And next, the validation is done to ensure that our numerical modeling will produce a convincing results. So a comparison between the numerical modeling and the experimental study for the HHS 25 millimeter times 25 millimeter and thickness of 1 mm was being done, and it shows quite a convincing findings where the discrepancy between the force for the numerical modeling and the experimental study is about 7.75%, and the displacement is about 2.64%, and is within the range that we can accept. So for the effects of ultimate strength, it can be identified from the force displacement curve as the peak force. So the thickness contributes significantly to the increment of the ultimate strength, and the thickness may actually give the major impact on the movement of inertia and stiffness that govern the axial capacity of the BOF-CFS column. So as we can see, the thickness is actually when the thickness is increasing, the ultimate strength is actually increasing for the three model. So the displacement is actually measured at the ultimate strength, which represent the yielding of the BOF-CFS column. And the relation between the displacement and thickness is embodied by the negative gradient. And regardless of the size of the SHS, the increase in the thickness is actually leading to the decrement of the displacements of the BOF-CFS column. And next will be the failure mode of the build-up CFS column. And the initial failure mode of a build-up CFS column is actually indicated by the building behavior before you experience the total collapse. So build-up CFS column is less susceptible to the buckling when the size of the build-up CFS column is getting larger. So similarly, the thickness actually will cause the lesser rate when the increasing of the deformation as the thickness of the build-up CFS column become thicker. And the failure mode may be localized or globalized across the size and thickness. So SHS for the smallest size, 19 mm times 19 mm, it suffers from the distortional buckling throughout the whole length of the SHS. And this figure shows the for the SHS with a size of 19 mm times 19 mm with a thickness of 0.72 mm and the largest thickness of 2.3 mm. As we can see, the thickness the thickness at 0.72 mm shows the greater distortional buckling in compared with the thickness of 2.3 mm. So next, these two figures also shows the SHS with the 25 mm and times 25 mm and SHS with the 32 mm times 32 mm. So overall, SHS of 25 mm times 25 mm and SHS of 32 mm times 32 mm will cause the build-up CFS column to experience the fractural buckling at the mid-height. So last, the conclusion. Okay, so this study was conducted to investigate the effect of section properties in terms of the size and thickness. So the numerical modeling was successfully performed using the well on the ultimate strength and displacement were quantitatively measured through force displacement curve, and the failure mode was observed visually. It was found that the ultimate strength of the build-up CFS column getting stronger as the size of the SHS become larger. And similarly, the thickness gave a favorable agreement. On the other hand, the displacements of the build-up CFS column shows a decrement trend when the size and thickness getting bigger and thicker. So in terms of failure mode, it was found that the build-up CFS column suffers distortional and flexural buckling as well as the connector and stiffener failures. So these are the references that involved in this paper. And that's all from me. Thank you.
Okay, thank you, Mr. Chiawi. Okay, now I open to the floor for Q&A session. Any question from the floor? Is there any question? Okay, if there is no question, I would like to thank again to Mr. Chia Wing Hong for the presentation.
All right, thank you.
Okay. Okay. Before we end of this session, I would like to announce that the GCOMSE 2021 committee proudly announced that there are two papers from this session was awarded as Best Paper Award. Okay. Okay. The first Best Paper Award goes to Dr. Dwi Agus Purnomo from Center of Technology for Transportation System and Infrastructure Indonesia with his paper entitled Initial Implementation of Structural Health Monitoring System of a Railway Bridge. Congratulations, Dr. Dwi Agus. And the second...
Thank you very much.
Thank you. Okay, the second best award goes to Mr. Chia Wing Hong from Structural Dynamics and Computational Engineering Focus Group UTHM with his paper entitled Effects of Section Properties on Structural Behavior and Failure Mode of Build-Up CFS Column. So congratulations to both of presenters.
Thank you very much.
Thank you. Okay, before we end our session, can everyone please turn on camera so we can take a photo for this session. Please turn on camera.
Okay, I snap the photo.
Okay.
Okay, ready? Okay, smiles. 1, 2, 3.
Thumbs up.
Okay, once
Thumbs
again.
up.
Okay,
Thumbs up, please. One more. Thumbs up.
one more. Sorry, one more. Okay, I count. 1, 2, 3.
Okay.
Okay.
Okay. Okay, thank you everyone. Thank you to all the participants. Thank you to the presenters, the participants. Thank you for the participation and cooperation until the end of the session. And hopefully we can meet again at GCOMSE 2023.
Yeah, thank you. Thank you very much.
Okay, until that, thank you again.
Thank you very much.
Thank you.
Thank you very much.
Bye everyone. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much. Bye. Thank you.
Bye.